Started for joining. Hopefully you enjoyed Andy's keynote. A lot of great announcements, and we're excited to be doing this a second year in a row for reInvent. My name's Joe Lyons, and this is a 100-level course. So if you're new to Amazon and you're trying to learn the basics, then you're in the right room. If you're more advanced, this might be a little rudimentary for you. So I'm going to try to do my best not to use acronyms, or if I do, explain what they mean. And I'm going to be talking about a number of things today. And I've been in Amazon for a few years now. When I started, we had really two products, our flagship S3, which I'll explain today, and EBS. And since then, we've launched Glacier, which I'll explain today. We've launched Direct Connect, the AWS Storage Gateway, so we've been innovating really fast. So today we're going to talk about scalable storage, and that's our flagship S3. We're going to talk about inexpensive archival storage, and I'll define a little bit what an archive means, because it's not for use for anything other than archive. We'll talk about persistent direct attached storage to support EC2 instances. We'll talk about our turnkey gateway solution, and then tomorrow we'll be coming up from iMemories, who's the CEO of iMemories, and she'll be talking about how her adoption curve has developed in utilizing AWS and what her roadmap looks like in her future use of AWS. And she actually launched her business the same year that we launched AWS. So in terms of data, we're constantly producing more and more data, multiple formats. Customers want access to their data anywhere, anytime, on any device. As I watched Andy Jassy's speech, I watched Twitter just blow up, which is a customer of ours. And in terms of growth, we have customers on top of AWS from a storage perspective that grow by a petabyte per day, just a single customer. It's staggering. I never thought when I got into storage 20 years ago, I would see this kind of growth, but it's massive. Many of those are consumer apps, right? We're all users of the cloud as consumers, but the enterprise, as you saw today, is also adopting the cloud for obvious reasons. You look at oil and gas as an industry, right? They've got sensors, thank you, all the way down to the tip of the drill that are producing massive amounts of data. And this is data that needs to be saved forever, right? We're seeing adoption in life sciences. We're seeing adoption in the financial sector with companies such as NASDAQ, who recently launched FinCloud about a year ago, which is a financial services-focused archive solution for financial services, dealer brokers, and it had to be worm compliant and SEC compliant. And they launched that on top of AWS. And when they came to us with the idea in May of last year, we want to launch this service, and we're not sure how fast our customers will adopt. And we want to offer it to more than just folks that trade on NASDAQ. We want to offer it to the financial community worldwide. It's expensive to keep worm-compliant data, meaning it's immutable. It cannot be changed, deleted, or modified until the retention period has expired. That's typically 7 years. So they turned to their internal IT team and said, how much to build it? They said, well, how big is it going to be? Well, we don't know. Okay, well, what's the adoption curve going to look like? We don't know. Okay, rough estimate, 10 to 20 million, about 18 months to put the kit together. So this is May of last year. By October, we launched FinCloud, and we helped them ring the closing bell in October, which was fantastic. They're now multi-petabyte level, and their AWS bill to develop the application was less than $1,000. So really compelling what the enterprise is doing. They're innovating now fast as the startup. And what they use is our object store, right? And it's called S3, which is Simple Storage Service. And it's called Simple Storage Service because it's very simple to use. You use very simple protocols like puts, gets, copies, deletes. Those are transactions on top of S3. And that's done via SOAP and REST APIs. And for those of you in the room that are not from the development world and you're from the data center world, you don't use SOAP and REST APIs. You're probably more familiar with protocols like iSCSI, CIFS, NFS. I'll talk a little bit about how you can use those protocols to interact with S3 just like you interact with traditional on-prem storage. And S3 is durable. It's the most durable storage subsystem on the planet to our knowledge. It carries 11 nines of durability. What that means is if you had statistically 10,000 objects in S3, you can expect to lose one every 10 million years. So very, very durable storage. Customers using S3 do not keep multiple copies elsewhere because we have the durability, we have the redundancy. And the way we create that durability is we have this concept of regions. You probably saw in Andy's presentation of 9 regions around the globe. Each region is made up of hardened data centers and clusters of data centers that are connected by private fiber. So when you upload an object into S3 or move a file into S3, for lack of a better way to explain it, multiple copies will be made and spread across the availability zone and across multiple availability zones. And some availability zones are actually made up of multiple data centers, which is why we don't call them data centers, we call them availability zones. So we're very, very durable. If you're a little bit familiar with AWS, you know as a customer you choose a region, number one. Number two, you say, okay, I want to build my app in this availability zone. And then if you follow best practices, you'll load balance between availability zones like Netflix does, for example. You don't need to make those choices with S3. You upload a file into S3, it'll be spread around the AZs and protected for you. And we have trillions of objects. It took us 6 years to get to 1 trillion, and we've almost doubled that in the past 2 years. So again, back to my earlier point, the data growth here is massive, and the scale of S3 is almost limitless. And we handle about 1.5 million transactions per second. Again, a transaction is a put, a get, a copy, a delete. So when you're looking at S3 and you're comparing the cost of, let's say, S3 to on-prem storage, you can't just look at your storage costs and maybe your replication costs between multiple data centers. You also got to look at that network stack, right? Because there's a cost, and there's a cost to I/O to access the storage, a cost of network to access the storage. We bundle all that together in S3. It is a service. So with S3, you have this concept of buckets. You create a bucket, and you put your objects or your files into that bucket using bucket names. And you can have an unlimited amount of objects, but only up to 100 buckets can be created. And if you think you need to create multiple buckets in order to create the scale that you need or to departmentalize the spend, there are many ways to do that. Dropbox is a big customer. They have millions and millions of customers, and they only have 2 buckets. So you don't need to create multiple buckets in order to create partitioning. We also have an option called reduced redundancy storage, which carries 4 nines of durability. So we have customers that say, you know what, I just don't need that much durability because of how I use my application. So Spotify is a great example of that. If you're not familiar with Spotify, it's MP3 as a service. So you can listen to music, and if they lose a file, they can replace that any number of ways. So RRS is going to save you about 20%. And basically all that is, it's the exact same performance as S3. It's just fewer copies across fewer availability zones, so there's less durability for that application. And that's fine for Spotify and for many customers. S3 can also be used as a static website. For as little as $100, you could run a static website for years on top of S3. It's an extremely efficient way to use a website for static content. And we constantly drive price out on S3. Right? S3 was the flagship product, the first product ever launched by AWS. We've done 16 price reductions since launch. Last year, we cut prices by 25% at reInvent. And for my customers that spend hundreds of thousands a month on top of S3, approached me and said, the last time I woke up in the morning and my storage vendor saved me 25% overnight without any negotiation, without any expensive RFP processes, was never. Right? We're going to continue to do that. And price is definitely on top of mind for our customers. And they're constantly doing TCO of on-prem versus S3. And that can be really challenging. It's hard to compare on-prem to S3. So customers will come to me and say, look, I look at a petabyte of storage raw that I buy from my storage vendor, and it costs me X. And I look at S3, and S3 is more expensive than buying a petabyte of raw storage from my storage vendor, my traditional storage vendor. But if you think about storage, when you buy it, the first thing you have to do is RAID protect it. And so you're going to lose 20% on overhead. RAID protection is a way to protect your storage against failures. So you only have 800 terabytes of usable for that 1 petabyte of raw that you bought. Then you're going to allocate storage to your users. If any of you are IT, you have departments that say, I need storage, I need storage. If I think I need a terabyte of storage, I might ask for 5, see if I can get that. I might not use it all. So there's allocated storage, and then there's actually what was written storage, which can be far less than what you actually purchased. I met with one financial services organization that was spending $20 million a quarter on new storage, and when we looked at their utilization from raw to written, they were 8 to 12% utilized, depending on the department you looked at. So there can be a lot of waste in storage. Versus on S3, you're only paying for what you're buying, It's 100% utilized. It's fully durable. And by the way, what you see on the left side of the screen, you have to do that twice because you need to replicate that to a second site if you're really going to protect your application. So if TCO is something you're looking at, if you're modeling out your costs year over year, it's very easy to model S3 because it's a simple price per gig. So if you're looking at your business and going, what are my costs going to look like year 2, year 3, year 4? It's definitely a conversation you should have with AWS. Right? We want to have that TCO discussion with you. We want to make sure that you're modeling correctly versus on-prem. So S3, unlimited storage capacity. If that's what you need, S3 is a great solution for you. Very durable. Storage for backup is fantastic for backup copy, using RRS, for example. And a single origin store with delivery via CloudFront. So S3 is close to supercompute, content delivery, which CDN, which is a network optimized to deliver content. So if you're in the software download business or the gaming business, you're probably using some type of CDN. And CloudFront is ours. So storage is the tip of the arrow. Many customers who are trying to get to know AWS will start with storage because you need to get the data in order to do something with it. And I'll talk a little bit about how we do that. But let's talk about Glacier first. Glacier was developed in conversations with our customers about a demand for a lower price tier that was extremely inexpensive, but there was no such thing as a trade-off on durability. If I'm talking about my long-term archive, it's obviously data that's important to me. I want to save it for a long time. So I can't have a trade-off on durability. But maybe I can trade off on how fast I can access the data. So we launched Glacier a penny per gig per month. So if you look at S3, it starts off at about 9.5 cents, so almost an order of magnitude cheaper. That's $120 a terabyte year. Again, this is fully durable, fully redundant, same 11 nines as S3 for that penny per gig per month. Same 11 nines of durability. Here's the trade-off. If you're going to use Glacier, it'll take 3 to 5 hours for us to return that file to you. And I'll talk about the different ways you can interact with Glacier. Okay, so you want to be, and you can retrieve up to 5% of your archive for free. But if you go over that, there's going to be a cost. So there's a difference between storage costs and retrieval costs with Glacier. Okay, so again, 5% drives the right behavior. When we looked at Iron Mountain and other off-site tape vendors that store tapes for customers in off-site vaults, we found that the average customer accessed those vaults about 2% of the time. Right? If you're going to push it off-site to a vault, you really don't want to be accessing it very often. So we doubled that plus a percentage and gave you 5% access to the data. You can access more than that, but there'll be a cost. So I encourage you to go to our website and take a look at Glacier and look at the retrieval cost. So again, it's not good for backups. Backups get accessed very frequently. Right? You want to use S3 for backups and then restore, and I'll explain how you can use lifecycle policies to manage between what's on-prem, what's in S3, and what's in Glacier. So Glacier, inexpensive long-term archiving. Right? Eliminate tape museums. Many customers actually maintain tape museums, backwards compatible drives that are no longer for sale. I've had customers do restores and have to go to eBay, and I'll talk a little bit about that, but no more tape museums. Eliminating tech refresh for your archive forever. Just set and forget. If you need it, bring it back. If you need to bring it back and compute against it or transcode on it, you can bring it back into AWS and remonetize that asset. And very, very durable. So after we launched Glacier, shortly after that, we launched AWS S3 Glacier integration. Okay, so that's policy-based archiving service. And I apologize for using some code here, but basically what you can do now is you can set a policy. And what you can see circled here is we have a customer that has a 30-day policy for data in S3. After 30 days, on day 31, the data automatically moves down into Glacier, where you can set another policy. In this case, it's 365 days, but that could be 7 years. Or it could be no policy, keep it forever. Right? You can also put a zero policy on S3. So as soon as you put the data into S3, you're no longer charged S3 charges. As soon as that put is made, we move it automatically to Glacier and you're paying a penny per gig. Why would you do that? You'd want to do that because if in the times when you decided, I want to restore this data, I'm probably going to restore it and use it in AWS versus download it to my PC or to my data center. So if you're going to use it in S3, S3 Glacier is a great integration because you can just move it right back in. So here's a typical archive recovery process for, let's say, a media company. Right? They have tapes off-site, and they decide, I'm not sure if you guys are familiar with Carol Burnett, but recently it was a 50-year anniversary, and they remonetized those assets. And what they had to do was go to tape. Those tapes get on a truck, they come into the data center, they pop them into a drive. They don't have that drive, they get on eBay and find that drive, especially if that tape's been sitting off-site for 35, 40 years. Okay? If they're lucky, 70% of the data will be restored. NASA recently lost about 30% of all the images of the initial moon missions because they put it on tape, they stuck it off-site, and data got lost on the restore. But let's say they find the drives, they spin them up, they restore what they can, they transcode it into the latest and greatest formats, one for the Wii, one for the Xbox, one for the Android, one for the iPhone. Maybe they push it out to disk, or maybe they push it out to CDN, and then they get new business value from that data. And that can take days, weeks, even months. Versus with Glacier. The asset was sitting in Glacier. I pulled a restore job, and a few hours later, I had it available to me. Pushed it through EC2 compute, transcoded it into 15 different formats, and then monetized it. So big advantage to Glacier. Typically, your archive is in a dusty, dark vault. You don't ever want to touch it. You certainly don't want to compute against it. When I look at NASDAQ and FinCloud and what they launched, I've noticed that their customers are actually doing more data mining than they are doing storage growth. So they've moved their assets over. They're under compliance, so they can't be modified in any way, but they can be copied and put into high-performance compute, and they can mine that data. And the financial services industry is constantly being crunched to do it better, faster, cheaper than the next guy. And data mining is a way to figure out, what are my customers buying? What else can I sell them? What customers are happy? What customers aren't happy? Right? What trade data happened today that I can take advantage of? So they're constantly crunching on the data. So it's a great advantage to have that archive next to supercompute for the first time. Complete Genomics is a great story of a customer that adopted Glacier. So Complete Genomics has a process by which customers send them genome data on CDs. And they send them to a service that we provide, which is called import-export. So we get those CDs and we import them into their S3 bucket. Then they run a genomics job against that data, and then they get a result and they push it back to DVD or CD, and we ship that back to the customer. And then they delete the core data that they received. So the customer technology improves constantly, and the customer says, you know what, I want to run another job against that same genome. And so, okay, resend me the disk. Well, that's an inflection point. What if I want to move over to 23andMe and use them instead of Complete Genomics? They just came out with a price change, or I saw an ad for them on Google, because they're number one if you're searching on Google for obvious reasons. But so maybe I'll use 23andMe, maybe I'll ship my data to them. Okay, so that's attrition. So what Complete Genomics did when Glacier came out, they said, all right, you know what? I can afford to keep this data now. So what they do after they run the genome job is they drop the core data into Glacier. And they've told their customers, by the way, don't archive a copy of your data. I've got a copy for you for free. So I'm going to archive that for you as a service to you. Oh, and by the way, if you ever want to run a new genome sequence, you don't have to call FedEx. You don't have to ship me a CD, wait for it to be ingested, and wait a week to get the data. I can run it in hours. So they've got better customer loyalty, better, faster, cheaper than the competition, less attrition. So a great way to use the data. And when we launched Glacier, we thought, we're going to see cannibalization of revenue moving from S3 to Glacier. But we didn't see that. What we learned is that customers were making a Sophie's choice with their data. They were deleting data that they otherwise wanted to keep but couldn't afford to keep. And now they're keeping it for a very long time in Glacier, or plan to anyway. So Amazon S3 is great when you're looking for an HSM, or what's called hierarchical storage management, right? Move the data to the appropriate tier based on how much access you need to that data, right? Using lifecycle policies to move data back and forth automatically. Archive data from S3, obviously, or RRS to Glacier, and you can delete data from Glacier by policy. So if you're under any type of obligations to save data for a certain period of time, many people do follow those policies, but very few people go back and delete the data when the retention period's over and expired, because it's costly, it takes time. You know, I've got a tape library that's spinning all the time with new data that I'm backing up. If I'm going to follow my retention policies, I need to call tapes back from some off-site vault. I need to dedicate some drives. I need to load them up. I need to find the files that I can delete them, refresh the tapes, recycle the tapes, what have you. That takes time, costs money. A lot of people just, you know, we set and forget. And that actually can add risk to your business. If the retention period has expired, that you don't need to keep the data any longer, you can set a policy and have it automatically delete for you. So our other storage offering is elastic block storage. Okay, so block storage is just like if you have a server and you directly attach storage to it, so that if the server crashes, the data persists. right? That's what EBS is for. The reason I like to, the way I like to think about EBS is it's only usable through EC2. So S3 you can use S3 and use nothing else at AWS, where for many companies we're their origin, and then they use other services outside of AWS, or they download the data when they need it. When you launch an instance of EC2, you can use the ephemeral storage, which is the storage inside the server, or the virtual server, if you will, which is fine if when the server turns off, and that's the value of EC2, right? Turn it on, turn it off when you don't need it. Well, when you turn the server off, if your data was sitting on ephemeral storage, it goes away. So if you want the data to persist, you would attach a 1 terabyte, up 10 gigs, up to 1 terabyte drive of EBS to your EC2 server, and if you turn that server off, the data will persist, and you can turn the server back on and reattach it. If you're following best practices, you'll actually do snapshots from EBS to S3 to have the durability of S3. So even though the max you can do on EBS today is 1 terabyte, you can RAID or connect multiple instances together of EBS to create whatever drive size that you need. For a long time, EBS, the performance of EBS was, it scaled up and scaled down depending on noisy neighbors and other things. And so if your application needed consistent performance, we really couldn't provide that in EBS. So a lot of ERP applications need consistent performance and predictable performance. So last year, we launched provisioned IOPS. So you can provision up to 4,000 IOPS for your EBS instance and anything in between in order to support what your application needs. And that has just blossomed the number of use cases for production applications that can move over to EC2 and S3 and EBS. So again, you launch an instance of EC2, attach an instance of EBS to it, and if your instance fails or you turn your instance off, you can fail over to another EC2 instance, or you can light up a new instance if you had turned it off, reattach the EBS drive to it, and your application's back up and running. And you can do multiple instances of EBS in order to meet whatever the need of the application is. And EBS snapshots are very important to do. It's a best practice, right? EBS, again, is not configured like S3. S3 is very, very durable. So anytime you're doing EBS, depending on what your comfort level is, you can do snapshots every minute, every 15 minutes, every hour. So you definitely want to look at doing snapshots with EBS if the data is important to you and important to preserve. And it's easy to do, right? It's simple, just set snapshot, and it'll move over to S3, and it'll persist there. If for any reason your EBS instance fails, your EC2 instance fails, pull the snapshot over, you're back in business. And here's a great example. Supercell is a gaming company that uses EBS at scale. They're an online gaming company. Gaming is very hard to predict, right? You don't know what game's going to hit. You never know what the great new thing is. Bitstrips is another organization that recently launched and has gone absolutely viral. And the same thing happened to Supercell. They're a big user of EBS. And the reason they're a big user of EBS is they like to run their own database. And you can move your database. If you own a license of Oracle database or SAP, you can move that over. That license can run in EC2, and then you can attach EBS to it, and you can run your own database in the cloud. So I've had customers that approached me and said, I'm not using your database services because they're too expensive. I said, okay, please explain. And they said, well, I'm looking at RDS, which is a managed database service that we have, and it's more expensive than running my own database. And so I said, well, do you like running your own database? Do you like doing patches and upgrades and losing nights and weekends from time to time? And like, yeah, we don't mind doing that. We're about capital preservation. We want to run really cheap. So it's like, okay, bring your license over like Supercell did. Run it yourself on EC2. And that's what they did. So EBS, long-term persistent storage, great for if your data is changing frequently, right? Block storage for your databases, as I just explained with Supercell. It's easy to create file systems on top of EC2 and EBS, and access to raw, unformatted block-level storage versus file storage or object storage. So I mentioned at the beginning of the talk that there are some customers that don't want to work with SOAP and REST APIs. They want to use CIFS, NFS, or iSCSI native data center protocols. So we launched the Gateway about a year and a half ago. And the Gateway is just simply a software appliance that you download. You can spin that up on an instance of VMware. It creates an iSCSI mount point, which most backup applications, for instance, can talk to. You point the application to the Gateway, and the Gateway will do a number of things for you, but it'll interact directly with S3. Okay, so if you've got an on-prem environment and you want to talk to S3 and now Glacier, you can do that. It's very inexpensive. There are a lot of gateways on the market, and we partner with many of them. So if you're looking at different ways to talk to S3, again, talk to us and we'll walk through the partners that are available depending on the use case that you're looking to attach to S3. And you can use this for a number of use cases. One, offsite backup. So you can put the gateway in backup or DR mode, and it will keep one copy of the data locally on your prem and a second copy in S3. But it'll do that as an EBS snapshot. So I talked about EBS, and you do snapshots to S3. This is using the same snapshot technology to move data from on-prem into S3. The value to you is that now, if you do need to fail over in DR mode, you can move the data from S3 into EBS, attach your application in EC2 to that, and then you're back up and running. So it's usable in S3. If you're looking at gateways that are doing encryption, compression, deduplication, proprietary technology, moving that data into S3, the only way you can reuse that data is to rehydrate it, which means pulling it back down the wire, pushing it back through that gateway that you bought, and then you can now present the data to an application and actually use it. It's great for data mirroring. So we have customers that create a VPC, and they just want to mirror data from on-prem into the VPC and run some type of maybe HPC job on their VPC, which is a virtual private network that you can create so that the assets you provision in AWS are only accessible from your network, not accessible from anywhere else. So it's a great way to create a secure environment in AWS. So data mirroring is a way where you're not necessarily moving the data to my S3 storage solution. You're moving it into AWS to do data crunching on it, to do transcoding on it, to run some type of job on it, maybe to push out to CDN. It's great for file shares. So you can set the gateway up in file share mode, which will create, if you set up the gateway, it'll create a 32 terabyte drive that's available to your users, and they can use that to share files. And it's great for small departments who are constantly coming to you saying, I need another terabyte, another terabyte. Gateway in file share mode is a great way to manage the needs of that department. And you're only paying for what they use versus what they're asking to be provisioned. Maybe you have consultants or interns that come in for the summer and they just need a temporary file share and you don't want to put them on your expensive NAS. A great way to use that for departmental file shares or for temporary file shares. And then we just recently announced a virtual tape library version of the gateway. So the gateway emulates a tape library. So anything you're using that talks to tape today can talk to the tape library. When tape is in the drive, the virtual tape is in the drive, it's on-prem, on local storage cache. When it goes to S3, it's on the shelf, but still reachable by the robotic arm virtually. And then when it goes into Glacier, that's like the off-site facility that you sent it to the vault. So it creates that HSM model for you. Very simple to use. If you are running backup applications today, nobody has to learn anything new. Just continue to back up as if you were going to tape, except it's a virtual tape. All this for $125 a month, so very inexpensive. So it's all about choice, right? There are lots of choices in terms of the storage solutions that you use, how you interact or integrate with AWS, whether or not you use a partner, or whether or not you use our AWS Storage Gateway. So really, talk to us, and we're happy to help you in any way. And I want to talk a little bit about choices. I'm going to introduce Tamara, who's going to come up and talk about iMemories, who was a company that launched at the same time as we did. I'll let her explain what they did. But since she launched at the same time of us, her adoption she had to make other choices when she launched the company, and now she's starting to migrate over to AWS for reasons I'll let her explain. So I'm happy to introduce Tamara. Yeah, just.
Thanks, Joe. Good morning. My name is Tamara Munson, and I'm with iMemories. We're based in Scottsdale, Arizona. To give you a little background on what iMemories does, did you know that every 2 minutes today, more photographs are taken than were taken in all of the 1800s? But there are still more physical photographs in existence than there are digital images on our mobile devices, on our laptops, on our hard drives. An estimated 90 million American families, I'm going to guess you guys are among them, have somewhere in their house, in their closet, in their attic or garage, a box of photos, slides, videotapes, or film reels, family memories. What do you do with those precious family memories? This is where we can help. iMemories gives you a place to take all of those analog memories, VHS, film, photo, slide, and all of the digital. So the photos and videos that you have on your phone or your tablet or your laptop, your camcorder, your digital camera, put them all in one place, and view them on any screen, anywhere, at any time. How do we make that happen? That's what I'm here to talk about today. I'm going to give you a little bit of background on our story, our history, as it pertains to our infrastructure, where we started, some of the challenges we ran into, and how we're looking to overcome those challenges. With that, I'm going to dive into our integration with Glacier, but I'm also going to talk a little bit about our other functionality that we're looking to move to the cloud. So as Joe mentioned, iMemories was founded in 2006, the same year that Amazon Web Services launched publicly with S3. So just because of the sheer timing of when we were founded, cloud wasn't really an option for us to even look at when we started looking at our infrastructure and architecture. The other aspect of our business that really made cloud not an option was the fact that digital hadn't really proliferated our world yet. You could maybe take a picture on a mobile phone, no video, and tablets themselves were still on the drawing board. So really all that we had were the camcorders where you had SD cards or USB drives, but it was really the analog assets that were the focus and the foundation for our business. So to manage or to convert those assets into something that you could view online, take that VHS tape, make a digital video of it, and then allow you to watch it online, we had a lot of physical equipment that we had to bring in-house, that we had to keep on-premise to make that happen. For every VHS tape, we had to have a deck that would play it. For every film reel, we had to have a projector that would play it. And then the photo and slide scanners to scan those the physical slides and photos. So our infrastructure grew naturally around that physical equipment that we had in-house. We had servers to capture those digital images as they came off of the deck or off of the film reel. We had storage to store those resulting files that we could then deliver online or use to produce a DVD. So as we grew over the 7 years, we started to see some issues with our infrastructure, because as the business grew, we added more physical equipment, which meant more files, digital files, which meant more physical servers, both for processing the assets that were coming in as well as for storing the resulting digital video. Our reliability was not really as high as we wanted. We were running risks of downtime due to any type of a hardware failure. That meant a less than ideal customer experience and a less than ideal operations experience. We had to triple our full-time resources to manage that growing infrastructure. We had to add more network, we had to add more power, and to the best extent that we could, we had to add more space. Our costs were highly variable. So the static, less frequently accessed files, what we call a source archive, the original digital copy of the converted tape or photo or film, were a lot higher than our costs were for the things that we were delivering more frequently, the videos that you were watching online, the photos that you were looking at online. So what we started to realize was that our rate of growth was driving the need for our infrastructure elasticity. We had to be able to expand, we had to be able to expand quickly, and we had to be able to do it in a manageable way. So the numbers that I have on the screen are related to our storage, because this drives where we went with Glacier. When we started, we had about 8 TB of storage on premise. 2011, that was around 3/4 of a petabyte. And then sometime late last year, we hit about 1.5 petabytes of on-premise storage. Very unmanageable. So we started looking at what our options were. We knew we needed to solve this problem. We could not continue to add capacity on-premise and keep costs under control. So we went through a little bit of a process in determining what we were going to do. We looked at what our needs were, our use case, and what our storage requirements. So our use case was all video and photo digital files, fairly large files when you talk about video. Roughly a 1-hour VHS tape In its raw form, the DV form is about 13 gig of memory. We decided that based upon patterns of behavior that we saw with our customers, we would like to keep a local copy of those files for about 4 months. Most customers, when they gave us something to convert, within 4 months they would be creating a disk with it, and we would need that original source video, that original digital file. And then we weren't really going to need to access it that frequently past that 4-month window. So maybe if they came back and ordered another copy of a DVD, or if they wanted the mobile encodings, if they were going to be watching on their mobile device and we needed to create those mobile encodings. So our storage requirements were durable, redundant, and secure. We really wanted a solution that would allow us to keep those files forever. No or low operational costs. I could not afford to add more people or more overhead to manage whatever solution we were going to select. I really wanted no new hardware, and I had the overall goal of off-premise because, quite frankly, we were running out of space. So once we identified our need, we needed to start looking at our options, and what we quickly found was that there was a baseline, if you will, when you started comparing solutions, and that was really the cost per GB per month. So we needed to determine what our total cost of ownership was for our on-premise storage solutions in order to be able to compare apples to apples. So Joe covered part of this already with regards to your raw GB versus your usable GB versus your consumed GB, and the fact that what you consume has to pay for the total cost of your raw hardware. So if you're only consuming half of your hardware, that's twice as expensive, right? Because you have to pay for that unused half. But the other things that we took into consideration were on the operations side. So like I said, we had to triple our operations staff to manage our growing infrastructure. So part of their time, a significant part of their time, went to managing storage. So that factored into our TCO. Facilities and power, we had to add network and we had to add power, so that had to be taken into account. And then maintenance. So once the hardware was out of warranty, any maintenance that we needed to do, those maintenance costs went to our TCO. And for doing that, Forrester actually produced some pretty good industry standard numbers that we used for those calculations. And on the hardware side, as Joe described, if you want 2 copies, you have 2 sets of hardware. All right, so once we laid all of that out and understood our TCO, we really looked at 4 different solutions, and I apologize for showing competitors' logos on the slide. So we looked at S3, we looked at Cloud Files, we looked at Google Cloud, and we looked at Glacier. And as far as most of our requirements, all 4 solutions met our needs. What really drove our decision was 2 things. One was cost, not gonna lie. Glacier at $0.01 a gig a month, pretty attractive. But the other one that really was of interest to us, that was probably even more important than the cost, was the fact that we had an SLA on those source archive files that we were going to put on Glacier that worked very nicely with the 3 to 5 hour retrieval time that Glacier has built into it. So those source archives, as I described, what we use them for are creating, when a customer wants to create a DVD, we need to make the MPEG-2 encoding. If they want mobile encodings, we pull those source archives in and transcode for mobile. The expectations on when those additional items, when that DVD is available, is really driven by shipping time. So we don't need the file immediately. We have really on the order of days to produce that disk and get it into the customer's hands. So at the end of all of this, evaluating our use case, our storage needs, our total cost of ownership, we ultimately decided that the best solution for us was Glacier. So talking a little bit more about our integration with Glacier, our infrastructure is evolving. So when we started, as I said, in 2006, cloud didn't really exist yet. And iMemories business was primarily focused on the analog assets, the physical assets. As we've grown, as time has moved on, digital has become more prominent, And our infrastructure has needed to evolve for growth reasons, but also digital and cloud have facilitated that. So we're truly in a transition right now in our business. So our initial architecture, circa 2006, everything was on-premise, centered on the physical assets and devices and servers. It was very expensive to scale, and it was a non-ideal customer experience. Our architecture 2.x, where we're going, we will always have on-premise infrastructure. We have to. We're going to continue to receive those physical items. There's no way to manage that in the cloud. But for everything digital, we can migrate to the cloud. So the 2.x is going to solve our scale challenges, storage and processing, reduce our costs, and provide the best possible customer experience. All right, so just as a pictorial of our 1.0 architecture, very simple. Digitization and encoding servers, storage volumes, and file management. Integrating with Glacier was very straightforward for us. We were able to leverage all of the pieces of our existing infrastructure, and we added a component that interfaced to Glacier. So that component, which I'm going to talk in a little more detail on, is our interface to the Amazon services. We're multi-region. Our Glacier setup is multi-region, multi-vault, and we're using simple notification services and simple queue services to manage the request response on the restores. We're using JMS internally, and so the simple queuing services was a natural fit. All right, Glacier Manager was all custom code. And what we did, I think that's very important, it was very important to us in managing our costs, our retrieval costs, was we built into that code the management of the 5% cap and the 4-hour download. And how we did that was using primarily chunking. We're dealing with large files anyway, large video files, so we wanted to guarantee that the file makes it all the way to Glacier, and we wanted to guarantee that the file makes it all the way back from Glacier when we need it. So we're using 10 megabyte chunks to both put and get the files. Every hour, we're looking for requests for files that need to be retrieved from Glacier. And every hour, we're calculating our 5% peak. So we determine whether, how much we can download in that hour. If we need to download more than what we can based on the 5%, we spread the request across multiple hours. Glacier Manager then also does the audit piece. As I described, we keep a local copy. When we're ready to delete that copy, we want to make sure that the copy is stored on Glacier like we think it is. So we run audits about 3 times a week, and we have no lost files so far. We also use it to generate our internal activity reports. Okay, continuing on our migration to cloud, our evolving architecture, we are also looking at, and in really an early production stage right now with S3. We have web viewable and mobile viewable files. S3 is the perfect fit for those files. So in a manner very similar to how we integrated with Glacier, we're integrating with S3. We have a custom piece of code that is responsible for making sure that all of the files that need to go on S3 get to S3. On the S3 side, we're using a few EC2 instances for streaming servers, so the delivery of those web files and mobile files. And we have really just one bucket right now holding all of those resulting video files. Our other step in our migration or evolution is the upload piece. So from your mobile device or from the web app, you can upload digital files to iMemories. And those files will be uploaded to EC2 instances and go through some processing. So we have kind of a landing pad, if you will, where the file first lands and goes into an S3 bucket. We do some processing on it. We notify our back end, our file management system, when those files are received and when they're processed. We're leveraging the video processing group. We're taking advantage of auto scale to scale that as needed. As uploads increase or decrease, we're automatically growing and shrinking the EC2 footprint. So in closing, I've talked a little bit about iMemories, our history, our story, our evolving architecture. I dug into a little bit on one of the first problems we were solving with Amazon Glacier, and that was our storage of our archive files. And I talked in a little bit more detail on some of the other evolutions that we have underway with our infrastructure. I hope that's given you a little bit of a sense of how cloud may help your business, how you might consider migrating to cloud, and even why you might consider migrating to cloud. So in closing, iMemories, we're enabling families to share memories in endless ways. And if you would like to take advantage of our services, we have a 20% discount that we're offering with a promo code, which I did not get onto my slide. It's AWS-2013, if you can remember that. And feel free to contact me at my email address with any questions. All right? Sure? Any questions now? All right, thank you.